Hello, this is Courtney Harris, coming to you for FTH 202 Revolvers course through SDI. Professor Christopher Becker. Today's date is June 22nd, 2025. Here is the revolver that we're working on. You see there's nothing in the cylinder, there's nothing in the barrel. All is well when it comes to that. So let's go ahead and take off the handle and the side plate. Alright, so the side plate is gone. So now we're going to delve into the cycle of operations and certain internal parts. So it is kind of dirty. I went ahead and ran some rounds through this sucker. So this right here is the hand. And the hand is responsible for making the cylinder rotate. So if you see right here, when the trigger when the trigger is engaged, the hand comes up, pushes the little gears in there, and rotates the cylinder. If the hand is to fail, we'd have a failure to rotate. That means that upon pulling the trigger, the cylinder would not advance to the next chamber, resulting in no ignition of the cartridge. Then we have the sear. The sear holds the hammer in a cocked position, allowing controlled release when the trigger is pulled. If the sear fails, we encounter a failure to lock, which can cause the hammer to fall unexpectedly or not at all, preventing revolver from firing. So your sear is right Sorry for the little break there. I needed to get something so I can point to it. But right in here, where my tip is pointing, that is your sear. And this as well is part of the sear assembly. So basically what that does is when you pull the trigger, you see how it pushes the hammer up right there. And a failure to do that means that your hammer is not going to go. If your hammer is not going to go into the cocked position, then you are screwed, for lack of a better word. But you are you can make it to where the hammer is going to fall unexpectedly or not at all, and again, preventing the revolver from firing. Next would be your cylinder stop. Let me go fancy little pencil here. This is your cylinder stop mechanism right there. This component locks the cylinder in place to prevent rotation until the trigger is pulled. A failure here results in a failure to align. The cylinder may rotate freely, leading to a misalignment with the barrel, which is extremely dangerous. And then finally here we have your hammer strut. It's a really long, very unique looking piece of metal. It has flat underneath the spring right here. Of course, it's a rounded head that fits into a groove of the hammer. This part's crucial for transferring energy from the hammer to the firing pin. If there's a failure in the hammer strut, we experience a failure to fire, and the hammer may not have enough force to strike the firing pin, leaving the cartridge unfired. Understanding these failures are imperative to understanding the cycle of operations to help with your maintenance and diagnosing issues with the revolver. Okay, part 2 of this video. We have our weapon in the vise. Still nothing in the chamber or anything. And then I have my cleaning rod with a patch shoved in the barrel. I have it marked at my 12 o'clock with my little flag right there. Sorry if it doesn't focus. Okay, so now I already marked right here. See it right there, the white. That is my entrance point. From there, I'm going to rotate the rod until the patch makes a full rotation. So I'm going to go ahead and push it in here. And then, boom, there we go. You see how my flag is down there, so that makes the full rotation. Let's pull it back out and do it again. Alright, flag at 12, pushing it in, and then I have my marker where it's an 8, so I'm going to go right there. See my flag turned, so I'm going to mark it right here, pull it back out. Alright, you can see my little line here where it entered and where it went to an 1/8 of a turn. The reason we use an 1/8 of a turn is because it's not a long barrel, so you can't get the full rotation. So we only use an 1/8 because it's the size of a full-size barrel. Anyway, so I have it at, let's see here. Let's turn 2 and 1/16 ish. Okay, so with my math, sorry, all I had was this piece of butcher paper. So our formula is going to be inches times the denominator of fraction, or the denominator of the fractional denominator equals your twist rate. So we have 2 inches times 8 and 1/8. That comes out to 16.25. But, so my math is mathin', but Taurus' site says that their firearm, specifically this 856, has a twist rate of 16.5. So somewhere I messed up, but that's what I have. So, with all of that being said, why does this matter for a gunsmith? Because you need to be able to correctly measure and understand twist rates. That way you can ensure that the rounds, specifically the types of bullets that you use in your firearms, are effectively stabilized. You don't want something that's too hot or too light and it's not going to perform the way it needs to. So it's a fundamental skill that can prevent misfires and improve your accuracy. So thank you for joining me, and we'll see you next week.